Hello, my friends. Welcome to Origins. My name's Don Chapman. It's my privilege to be your host. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. I have an incredible scientist with me today. His name is Dr. Stephen Austin. He is a field research geologist with a PhD from Penn State University. We like to say that here in Origins. Now, I'm intrigued by your title for today. We're talking about mudflow madness. What does that mean?
Well, sometimes scientists take an adventure in thinking, and we often will go beyond or where the evidence points us to go. And sometimes we find paradoxes and things that just don't make sense intuitively in the world we live in, and so we need to go live in a different world almost to explain things. So when we get into that kind of abstract theoretical world, it's almost madness, and you look back on you and you say that's the way we need to think about a certain subject.
And you made a major discovery there at the Grand Canyon.
Yes,
fossils.
I started discovering fossils in Grand Canyon in 1987, and every year since I've been going back finding more.
Wow! And this fossil is a fossil of what?
It's a squid. Fossil squid. We call it a nautiloid.
Okay.
Nautiloid. And here you see the image of a nautiloid. It's an ancient marine animal resembling a squid, which lived and was housed in this solid chambered shell.
Well, now, I know you have a lot to show us today, so I'm going to ask you to go up to the board and help us to go on this journey with you into mudflow madness, will you?
Yeah.
All right.
Okay, well, here is the layer in the Grand Canyon region that I'm explaining.
Now, that's you down there in the corner.
There I am. I'm at the Interstate 15 road cut, Arizona mile marker 13.3. The red wall limestone, which is in Grand Canyon, is exposed in a road cut on the interstate highway. And what do I see? I see this rather thick bed sitting in there and massive layer that's maybe 1.5 times my height, so it's about 8 or 9 feet high. It's this layer, this one part of it, that I call Whitmore nautiloid bed. That's the thing that I've been studying. And it's very widespread. It's about 200 miles long east-west. But it occurs in Grand Canyon, and it's in the middle of the Grand Canyon at what we call the red wall limestone. Let me indicate that right here for you. There's the red wall limestone. It's about halfway down from the rim to the river, so it's down there about 2,000 feet below the rim. This red wall limestone, near the bottom of it, maybe 100 feet above the bottom, is where I find the nautiloids. Okay. Here's that layer, and you can see it in exposure. It's about 7 or 8 feet thick through most of the canyon. And then it has underneath it some grayer colored limestone. It's kind of brownish. And then above it is this thinly bedded limestone and a rock called chert. And then right about the middle of the bed, right about 4 feet up the 8-foot thick layer, in there is where we see the nautiloid fossils. And here's a large nautiloid fossil. I never find them stacked on top of one another.
Okay, they were all laid out in the same, like they were all swimming in the same thing or something.
Yeah.
Okay.
Okay, and that's part of, well, I got to explain that, right?
Right, right. That's your compass?
Yep.
And your compass would be
that's
what?
about 3 feet long. We're looking at a nautiloid. The tip end of a nautiloid is about 3 feet long. The average nautiloid fossil is about the length of your arm. Some of them may be 7 feet long.
Wow.
It looks like these things crashed into this layer as it was accumulating.
All right.
Okay, about 1 out of 7 is standing vertical.
All right.
1 out of every 7 is inclined. And what's interesting is the internal structure. There's a structure on the nautiloid shell called the siphuncle. I can circle it here. It runs down through the tip of the shell, and that thing has a tube running down through it, and that's very distinctive of the different species of the nautiloids. And so that's why I'm dealing with a different species. I know that structure defines what a nautiloid is. Then you can see the pressurized chambers around it. and that tube went down through the tip end of the shell, and they pressurized the thing. So it's like a submarine. It can adjust its density and buoyancy.
Wow, so it can go up and down that way.
Going up and down.
When it was swimming, okay.
So it's a swimming animal.
Uh-huh.
So it's the top predator in the ocean, okay? And you can have some mighty mean dreams imagining 7-foot-long shells with what? Another 3 or 4 feet of squid tucked in there on the end. So these could be 10-foot-long critters. Wow. So anyway, they're big, okay?
I wouldn't want to swim with them, okay.
Okay, yeah, you don't want to swim in the surf with these guys.
All right.
Okay, let me tell you a story how I found them. In this slot canyon called Nautiloid Canyon, along the Colorado River, 34 miles downstream from Lee's Ferry, where the rafts launch to go into Grand Canyon. 34 miles down. In that slot canyon, in 1987, a boatman showed me 12 nautiloids sitting on a ledge. And these nautiloids were sitting on a limestone ledge there in that canyon. And there's a nice campsite right next to it. The fossils on the ledge and the campsite, it made a very nice place to pull in. And so I got fascinated because the nautiloids, the big nautiloids are all on that one ledge. And by 1995, I had a hypothesis about the Nautiloid Canyon fossils. I found 12 the first year, and I brushed off the ledge, and I found a total on a 320 square meter area, 80 nautiloids, 80 straight-coned, straight-shelled large nautiloids sitting on a bedding surface, all coplanar or in that one horizon in the middle of that bed.
Now, it was already called Nautiloid Canyon.
Because of those 12 fossils.
Because of the 12. And then you went in and found that there weren't 12, there were 80.
There were 80.
Wow.
Okay, so I went in there and found the 80 fossils, and I mapped them, made a detailed data collection. The 80 nautiloids are sitting there on that ledge, okay, right next to the campsite. So that was ready to happen, okay? And so, but the important thing is, I was thinking about a mass kill event. The way the animals were buried and crushed, as if they were under pressure, were squeezed, the way they were buried with orientation, a lot of things about all being in the one layer, argued to me that it was a mass kill. In other words, something killed them.
They all died at the same time.
They all died at the same time, and something whomped on them.
Okay.
So I'm working with that hypothesis as a sedimentologist. I'm studying sediment and fossils, and so I'm thinking about this. But by 1999, I started asking another question. How big is it? How big is it? Okay, there's 80 nautiloids on 320 square meters in that slot canyon called Nautiloid Canyon. There you see Nautiloid Canyon, the convenient place to pull in. Look at all those ledges along the river. See these ledges?
Yes, sir.
You could potentially pull in there. And so I got permission from the national park to bring a power boat in to study the nautiloids or anything that was on those ledges. And what I found were hundreds of nautiloids on all of those ledges along the river, along about 3 miles of river.
So we moved from 80 in one location to hundreds in multiple locations.
Yeah, about 350
okay.
Along the 3 miles of rivers. I found those. So all of a sudden, I'm seeing hundreds of nautiloids. I studied the layer from as far east as Marble Canyon, 34 miles below Lee's Ferry, and Marble Canyon, eastern Grand Canyon, all the way through Grand Canyon, through Lake Mead area, all the way out to Frenchman Mountain in Las Vegas. So there it is. It's one of the world's largest fossil deposits, and accidentally discovered it. Okay, now here's some technical points. We looked and measured the size of these organisms because we have lots of them, and we discovered something. They're not all the same size. They have various sizes.
I see what you're saying. It's a broad indication that everybody was there, the whole family was there, sort of.
Yeah.
Okay.
So I think because of that I'm looking at a mass kill.
All right.
Of a whole community of organisms that were living and then got whomped on.
All right.
And so something whomped on these guys. Okay, and the other thing I noticed was the orientations. Now, I studied hundreds of orientations, and but it led me to believe that there's a dominant orientation. Now, it's actually 4 different orientations that are dominant. The thing to see mostly is there's a direction that the nautiloids are not pointing to. And so it allows me to imagine these organisms being oriented in a current. Okay, some type of flowing current. And it tells me which direction the current is flowing because the way they orient. And then, of course, 1 out of 7 is standing vertical in the bed. So we have all of this orientation data that's extraordinary. The big question for me is, how did the coarse fossil debris get deposited in the middle of the bed? The coarse fossils, not just nautiloids, but corals and other organisms right in the middle of this bed, right all along here, they're all in there. All those big organisms, football-sized coral heads, all kinds of marine animals like brachiopods, bryozoans, crinoids are in there, and that needs an explanation. And in 1999, it became very prominent in my mind that I needed to do this new way of thinking about how sediment was being deposited. And of course, these mud flows, like the Pinatubo mud flow from the eruption of Mount Pinatubo in the Philippine Islands, these high-speed mud flows came to my attention. And I was thinking about mud flows and thinking about their physical characteristics, how they're like ketchup in a way. These are sticky when they're not moving, ketchup. In other words, thick and viscous. It wants to stay on your hamburger. But when you squeeze the ketchup out of the nozzle of the bottle, you want it to be liquid. Okay, that's what these mud flows do. These mud flows behave like ketchup. They're shear thinning. They lose their viscosity as they move and they get agitated. And the agitation creates this amazing property. And so I've started to think about high-speed, low-friction flows as I looked at these mud flows. Imagine a world without granular friction. Let's call it no friction land.
All right.
Sand would not form piles. What would happen? As you pour it, it would shoot out as sheets. Okay. Now, here's what I imagined. I imagined little springs between sand grains, and as you have the sand grains fall onto the surface, the springs keep them separated, and you disperse your sand as it goes into frictionless flow. Well, in no friction land or low friction land, I can imagine how sand could form sheets. I imagine what I call a sediment gravity current. A sediment gravity current is a flow, essentially over a horizontal surface, of sediment dispersed in water. And it's about 50% sediment, about 50% water. And as it flows, the bottom part of its laminar flow, in other words, it's sheeting one over another. The top of it is turbulent because of the interaction here. And then what do we have? We have the coarse fossil material in the middle of the bed. And so by high speed flow, I'm able to imagine how the coarse fossils could be deposited in the middle of the bed in a high speed, low friction granular flow. And this was produced in a laboratory when a ton of sediment was dropped down a chute and photographed at high speed. They understood from the experiments that the large objects were suspended in the middle of the flow. So as a flow like this occurs, it could congeal to form the fossil deposit that I imagine. And so my brain came out of no friction land the day before Thanksgiving weekend in 2004, and I've kind of worked out the physics of how high-speed flow of muddy particle, sand and mud, could make something so unusual as this bed. With an electron microscope, I was able to see the particles that were in between the sand grains in the limestone layer with the fossils. There's lots of small, very fine particles clay size and silt size particles that I think are the thing that make this high speed, very low friction flow possible. Okay, so we have the mud flows like at Mount Pinatubo in the Hawaiian Islands, the volcanic area there, these high speed mud flows. Imagine that underwater, and then imagine how far they can go, hundreds of miles in low friction flow. That's
so
what I'm
add
imagining.
to the dynamic of that mud flow that it's underwater, and that adds a whole nother dimension. We've got to take a break. Don't you go away. We'll be right back.
Today's guest on Origins, Dr. Steve Austin, is a field research geologist with his PhD in sedimentary geology. He is senior research scientist with the Institute for Creation Research. He has been involved in geologic exploration for 40 years on 6 of the 7 continents of the world. Steve has also done extensive field research at the Grand Canyon and Mount St. Helens. He is the author of several books, videos, and more than 30 technical geology papers. One of his books, Footprints in the Ash, deals with the 1980 eruption of Mount St. Helens. Dr. Austin can be reached at Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229.
We are back with Dr. Stephen Austin, and we're talking about mudflow madness, and we've come out of this imaginary land where there was no friction to hold sand down. Start to apply that for us to reality and where we live today.
Yeah, we're back. We got to live in the real world where there is some granular friction.
Yes, sir.
But we imagine these very low friction flows. Let me explain to you how I think or came up with this idea about the way things flow. The first thing I saw was this paper by Potsma in a science journal, Large Floating Clasts in Turbidites. And he was trying to explain how rocks got trapped in the middle of sandstone layers. And so large floating clasts in these sandstone layers was explained by Potsma by a rapid flow process. Then I had the experience with Mount St. Helens. At Mount St. Helens, I had experience with the deposits from high-speed granular flow. They're called pyroclastic flows.
You did extensive study at Mount St. Helens, didn't you?
Fortunately, I was not there during the pyroclastic flows. Okay, those are high-speed, 100-mile-per-hour granular flows of gas and hot particles.
Right.
But they made layers like this, okay, that I'm trying to explain. So, how do we make thick strata sequences quickly? That is a big question, especially since I believe in Noah's flood, and I believe that there's a global flood in the strata at Grand Canyon. I got to know the physics of how the strata were made quickly. And how were they made quickly? Well, they're made by, I think, a large part of the strata were made by these sandy gravity currents, these very unusual low friction mud flows. I believe they're submarine. In other words, they're underwater, and the water that they're in, the ocean, supported them buoyantly. So that helps them move and stay supported. And I believe they're sandy, about 50% sand, a lot of silt and clay-sized particles, but also coarse fossils. And so when these things flow, they make amazing layers. And I believe they're liquefied. In other words, there's poor fluid pressure between the grains that keep these particles separated. And the liquefied condition of the slurry makes for the low friction properties. Think of it as little springs between grains that keep them apart. And then this flow is laminar. It's a very low friction type of flow. In other words, it streams in a essentially a unit, and it's called laminar or non-turbulent flow. And then I think it goes fast enough, maybe 15 or 20 miles per hour, these things flow, and they generate enough pressure so they hydroplane. They build up enough pressure so they actually are lifted off the surface. So I believe what is going on in no friction land can be applied in these very unusual cases. And so we can explain a level layer 200 miles long across Arizona into Nevada by this mechanism.
You've got some words here that when they all put together, they make a certain condition. Submarine,
Yep.
that means the whole flow is underwater. Liquefied, that means that there's liquid between the particles, suspending them.
Yes.
Hydroplaning means the effect of, we all know how a car hydroplanes it, the water keeps it off the ground so it keeps moving. Sandy gravel current is what it's made out of.
Sand, and it's a gravity current. It actually flows with gravity on essentially a level surface.
All right, now I'm trying to, I'm tracking with you, my friend. All right.
So that's the imaginary world that I'm in, right? And I believe
sense with those words to me.
that nautiloid bed formed in minutes. Okay, from the passing of 25 cubic miles of sediment.
Okay.
And the back surge generated the strata above, maybe 100 feet of strata above. And all of a sudden, I'm explaining large thicknesses of strata in the Grand Canyon by rapid, very catastrophic process.
And you're believing that this all happened while the Earth is underwater?
I think it's obviously, Arizona is underwater. Yeah,
so it's becoming a confirmation of a worldwide flood.
It is. Okay. So it's a canyon-length area. It's an ocean floor collapse event, gravity collapse event. It's a gigantic sandy sediment flow or slurry flow. There's a mass kill of nautiloids. It's swept up the fastest swimming predator in the ocean, like a vacuum cleaner just ingested them because it can move faster than they can move. And the dead nautiloids were swept into the flow. They were buried in the lime sediment. The back surge or the recoil created the thin beds that are on top of the nautiloid layer, those thinly layered limestone and chert layers are sitting on top. And then the last part of the interpretation, the limestone strata were deposited in minutes, not millions of years.
So this happened quickly.
Very quickly.
Very quickly.
Yeah.
Boom.
And so it is, that's the world that the nautiloid layer has led us into. Here's some good conclusions. Grand Canyon appears to contain one of the world's largest fossil deposits.
That's an absolute fact.
Well, it's 100 miles, over 100 miles long through Grand Canyon.
You can refute that. They're all there.
Yeah, okay. It's all in one layer.
Right.
And it's one of the world's largest fossil deposits. I don't know of any fossil deposits larger than that. It's a gigantic seafloor collapse and flow event that's responsible for the mass kill and the burial of the nautiloids.
Okay.
And then, to me, the conclusion about the story, that it leads us to, how it's discovered, how it's described, how it's interpreted, this extraordinary event is itself an interesting study in the progress of science.
It really is. Now, you've written this up, and what's the response that you get from the
I've given this
scientific
presentation at science meetings, and people like thinking about this.
It seems to me very hard to refute.
It is.
All right. Very good.
And there we are, the Grand Canyon, Mudflow madness.
Well, I can understand how you enjoyed all of those nights, the exciting time you had in the Grand Canyon. My friends, I just want to say to you that there is no way to explain all of these fossils of the nautiloids unless there was a worldwide flood that had these mud flows as a part of it. There doesn't seem to be a second explanation.
It's so amazing that it challenges our mind to believe in a global flood.
And if you believe in a global flood, you'll believe the rest of the Bible. And if you believe the Bible, you'll not only know that God made nautiloids, but He made you. And never forget this, my friend, it's God's view that He made you. And that should be your worldview too. Hope to see you again soon here on Origins. Until then, God bless you, my friend. Thank you very much.
Thank you for watching this edition of Origins. If If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 1010 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1010, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.